Good day, my name is Vinasri Ravichandran. Today I'm going to be explaining about the code and the output for the assignment 3. So I'm going to be explaining the part about the image without shadow, which is the shadowless image. So this is the part of the code for the shadowless image. So firstly, when we see the function firstly checks if the input image has a 3 dimension, which indicates whether the color is actually in a background format, whether it's in grayscale format. And then if it is, then the code converts it to grayscale conversion. If the image is already in grayscale, it is kept as it is. It doesn't change to anything. The next step is this part is the next step involves calculating a binary mask using adaptive thresholding, where the CV2 threshold function is applied to the no shadow image, the shadowless image, using Otsu's thresholding method. Moving on is to this part, where the background of the image is created with the same dimension as the input image. This is done by multiplying with 255 to create the white background. Moving on to this part, here the original image and the white background are combined using logic OR operation, the bitwise OR operation, which is to combine the original image and the white background which was created before this. And moving on is to this. This is used to finally to invert the result using the bitwise NOT operation. So this step is done to get the final image, which where the shadows are fully removed. If there is any shadow. So now let's run the output. Okay, so this is the output. Here we have a user interface, a menu where all the image which are processed will appear. And if we click this tab, you will be redirected to the folder here. But we can also directly choose from here. So there are 2 images which have no shadows, which are image 1 and image 3. So I'll just show the example. So when we click on image 1, this is the image before and this is after processing. So you can see that it is clear that the background has turned white and the signature is popped up. It became even darker. And moving on to image 4. So image 4 also, this is before and this is after. So you can see that the background is white and the writing has popped up even darker. So image 1 and image 4 has went through the same method, which is adaptive thresholding method, because it has no shadows in it. That's all from me. Thank you.
For image 2, we implement color-based segmentation and thresholding techniques, which are fundamental to image segmentation. We use this concept to apply for isolating and processing specific regions of interest in an image. The function isolate the text image takes the input image and isolate the blue text from it. The blue text is identified based on its SSV, hue, saturation, value, color range. The function creates a mask, blue mask, to identify the blue region to white. The result is stored in the variable isolated text. I will show you the program. When you run your program, you will see this menu. And let's try to run the process image 2. Here, it will show you the original image. And next is the process image. You can see here the code perform the segmentation by isolating value set from the rest of the image based on the color segmentation. Because we from our code SSV, we isolate the blue text, so it will select the image from the image with the text. And we will also use the thresholding, the color thresholding, especially to identify the blue region in the image. It's a form of thresholding where the pixels that falling in the specific color range are considered the blue color. So in summary, the image 2 isolate the blue text using isolate blue text function. And then we combine the output, the original, and then process image. That's all for my part. Thank you.
Right, hello, I'm Imran from group 7. So I'm gonna continue on with the assignment 3 coding for the process of shadows. So at first it loads the image in the path, then detects that if it can load the image, so it starts with the first process. This is for the image 2, which will be explained, and then this is the part where I'm going to explain. So it only detects for image 3 and the image 5 is in the path. So at first it will split the image into the RGB pixels. Basically, if the image are colored in RGB, it will split the 3 channels for each color and then create array result planes, and then result norm planes. Now calculation. So for plane in RGB pixels, for each plane, you will dilate the image, then use the medium blur, use all the set parameters, the difference of the image, then finally, and then normalizing it, and then at the end, they will append the process. Like so, for the result planes is the difference, and then the result norm planes is the normalized. Then it will merge. Then we go to merging the results. We declare the shadow image for a merge of the result norm claims, basically all the image in that array, and then combine the image, declaring a concatenation. Basically, for the display, we combine side by side in using the number one axis, so it will be horizontally arranged, and then resizing to make sure on the 800 height, 400 width. And then we then display the output. And then for the last section, this is for other image process. If there's no if the path of the image is in any or image 2, 3 or 5, we'll just call it to the shadowless function up here, and then you just concatenate and then resize it, then show the same process. So now I will run it. There we go. Now we got the GUI here, image 1, 2, 3, 4, 5, and open image. So I'm going to open image 3 first. So we got the folder here. There's the result. So I press process image 3, and this is the result as well. So you can see it removes the shadow for a clearer vision on the writing. Then we go to process 5. The shadow isn't apparent here, but the shadow now is much more clearer. Right, that's all for me. Thank you.